76. Where is it? 76. I see it. 1 plus tangent over 1 minus tangent equals cosine plus sine over cosine x minus sine x. Which of these two should be our starting point, though?
That's
yes.
fine.
Yes.
Makes sense.
So let's start with the left-hand side. I have to copy it. 1 plus tangent x over 1 minus tangent x. And then I will do 1 plus sine x over cosine x and 1 minus sine x over cosine x. Again, algebra. My calculus students always tell me, oh, calculus easy, algebra hard. How can you even think of calculus without algebra? So, which is? And then the top? Yes? And the top? Of course, when I flip, these two go away, and I have cosine x plus sine x over cosine x minus sine x, which is obviously correct. Anything else? Would you like to choose anything else? Or we move on? For example, 78 has some buzz to it. I don't know. I'm just looking. What else? '85 is a tougher one because of a formula that I did not put as an agreement. It's a very important formula, but I didn't put it as a basic agreement formula. So please choose.
85.
85 it is, because I would like to talk about that. In 85, we have sine cubed x plus cosine cubed x over sine x plus cosine x equals 1 minus sine x cosine x. So this is another identity. We understand that there is no argument here. We just have to show how we get from one side to the other, or how we simplify both sides to the same thing. So obviously, where will I start? Yes. Before that, let's discuss the following formula. What is this? Exactly. Let's discuss it. A cubed plus b cubed. And also, I would like to refresh your memory on a cubed minus b cubed. So the first one is the sum of cubes. The second one is the difference of cubes. Both of them will factor into a binomial times a trinomial. Okay? So a binomial times a trinomial. Bi, tri. The binomial is easy to identify. The trinomial would be easy too, but the binomial says this. What do I cube to get a cubed? Yes. And of course, a minus b. The sequence of sign is very important here. So please remember, if you're factoring the sum of cubes, the binomial has the sum, but the trinomial has minus in the middle. This is always positive. That's why I don't even mention it, the third one. So if we factor the difference, then we start with the difference, and there is the sum in the middle. And this is very similar to our agreement. Everything is the same here with our agreement without the 2. There is no 2 in the formula. So the first term squared minus without the 2, AB. And the last term must be in both cases what? That's it. Very useful to have under your belt. Very useful. The sum of cubes and the difference of cubes. So let me write this for you. Sum, difference of cubes. Of course, the first one is the sum. So now I'm going to ask again, which side are we going to start? Of course. So the left-hand side, that equals sine cubed x plus cosine cubed x over sine x plus cosine x. I want to add something here that you may want to remember about these two formulas or special products. If, and I'm going to write this down for you, if these two have degree 3, because they may have degree 6, they may have degree 9, but if they have degree 3, this is never factorable, it doesn't have solutions, it's always way above the x-axis. So this quantity will always be positive, always. Again, if this has degree 3, this quantity is not factorable, it does not have real solutions, and it's all way above the x-axis. It's always positive. But only if the original binomial, if the original binomial has degree 3. Not 6 or 9 or anything else. So I'll say here note. I'll write it after I finish this so I don't interrupt it. Or I can put it up here. Degree 3, result, a squared plus or minus ab plus b squared, always greater than 0. Not even 0, always positive. So if a cubed plus b cubed or a cubed minus b cubed has degree 3, then that quantity, which is the trinomial in the factored form, either with plus or minus, will be always a positive number, no matter what. So now, where do I start? What do I do? Yes.
So sine x plus cosine x and then sine squared x minus sine cosine plus cosine squared.
Very good. Awesome. So we applied the sum of cubes, and we wrote the binomial as sine plus cosine, and the pattern follows the agreement that we have for 2 months and a half. So the first term squared minus, without the 2, AB plus the second term squared. What will I do next? Assuming all conditions are fulfilled, although this amount could never be 0. How come? Because there is no angle that has sine and cosine 0. There is an angle that has sine 0, and there is another angle that has cosine 0, but there is not one angle that has sine and cosine 0, so that sum plus the sum of sine plus cosine will never be 0. Okay, so what do I do?
Factor out the sine.
Simplify, and then look inside and tell me what is left. And yes, it's not, you're not cheating if you are looking where you are trying to get to. So what?
Sine squared plus cosine. Sine is equal to 1.
Yes. So 1 minus sine x cosine x and equals the right hand side. Right. Any questions? Any questions? Is this okay?
Yes.
Good. So now I would like to continue with 7.2. We can always go back to other identities. 7.2 deals with the sum and difference formulas. So far, everything we studied in this class, we really proved it on our own. This time, I'm going to ask you to memorize 3 things. Even when we calculated 1/2 and the square root of 2 over 2 and the square root of 3 over 2, we did it on our own. We established that on our own. I didn't say, hey, remember these numbers, right? We looked at the right triangle in the unit circle, and we determined all those sides, and we identified that for pi over 6, sine is 1/2, cosine is the square root of 3 over 2. For pi over 4, both of them are the square root of 2 over 2. And for the last one, our reverse of the sine of the 30 degrees. Even that, we proved. This one, however, I would like you to remember it. Okay, there are 3 different formulas here. Of course, one for sine, one for cosine, and one for tangent. Okay? So, what does this mean when we talk about the sum formula? We talk about sine of a sum of 2 angles. And no, we wish it were sine x plus sine y. No. You cannot distribute. This is a function applied to an argument that is x plus y. And the formula is this. Initially, you may not like it. Sine x cosine y plus sine y cosine x. So never to be distributed to x and y. This is the sum of 2 products. So what am I saying here? As an example, I'm saying to you that if you want to determine sine, let's say, of pi over 6 plus pi over 4, and you don't want to calculate this, which if I do, the denominator will be 12, so then I have 2 plus 3, 7 pi over 12. I have no idea. But in this case, I will determine the exact number. I will have to replace it by sine pi over 6 times, yes, plus the reversed, sine pi over 4, cosine pi over 6. I know all these numbers. I will plug them in, and I will get the sine of whatever that is. 7 pi over 12, which otherwise I would have had to use a calculator for, because I don't know what 7 pi over 12 is. Even if I find where the angle ends, it's over 12. I'm limited to 3. Over 3, over 6, and over 4. Over 12, I have no idea what that is. So let's continue. Sine pi over 6. It's the top angle, the first one, the smallest. Yes? So sine pi over 6 or sine 30 is? Very good. Multiplied by cosine pi over 4. That's it. Plus, see, we are reviewing for the test. Sine pi over 4. And cosine pi over 6. It's not 1/2. Right? And we will simplify this a little bit by pulling out the common factor. Again, factor. This is the common factor. Let's pull it out. It's the square root of 2 over. Good. And in parentheses. That's it. And this will be one of the problems on the next test.
So why do we have that last one?
I have to simplify. Okay, this is the sum. So sine applied to a sum of angles. Sine applied to a difference of angles will be this. If I apply sine to a sum of two angles, I have sine x cosine y plus sine y cosine x. And if I apply it to a difference of angles, I have sine x cosine y minus sine y cosine x. So that's one formula. Now let's talk about cosine. We have a formula for cosine of a sum of angles and cosine of a difference of angles. So cosine in parentheses x plus y, this is not the same. Here it is. Cosine x cosine y minus sine x sine y. So when I apply cosine to a sum of angles, I have a difference of two products. And they're not the same with the previous formula. These are completely different, right? Cosine, cosine, sine, sine. What do you think will happen when I want to find cosine of a difference of angles? Exactly. The signs are reversed for cosine. And the last one is for tangent. Tangent of the sum is a ratio. The top is tangent x plus tangent y. And the denominator is 1 minus their product, minus tangent x times tangent y. And yes, what do you think will happen when we want to find tangent applied to a difference of angles? And the bottom will be, okay. Let's look at problems starting from page 505. And of course here we'll have expressions to simplify and identities to prove, of course. Tell me when you're ready. We want first to pick from 3 to 14 first. Then we want to pick from 15 through 20. And then from 21 through 50. Which one?
Page 505.
Yes, page 505. Ready? Which one? We want to try 8. Good. We are asked to find tangent 165 degrees. Here's the question. Use an addition or subtraction formula to find the exact value of the expression. So tangent 165, so this is 180. So 15 degrees shy of it, right? So the reference angle, not that it matters at this moment, is this is 165 plus 15 is 180. Okay. I could write tangent 180 minus 15 degrees. Okay. If I go this route, I have to use the formula for the minus. It will be a ratio. I will have to write tangent 180 minus tangent 15 over 1 plus tangent 180 times tangent 15. I personally would have not gone this route, but we started. Let's finish it. Okay, tangent 180. And you can say, didn't you tell us not to remember tangent 180? And I would say yes. But now you have to remember tangent 180 is sine 180 over cosine 180. And then you will tell me what tangent 180 equals to. How much is sine 180? Sine is measured on the y-axis.
0.
0. So then 0 over negative 1 is 0. So then I have negative tangent 15 degrees. Since this is 0, then this is 0. Over 1, because 0 times tangent 15 is 0. 0 plus 1 is 1. So now I have to determine tangent 15 degrees. Negative is outside. It has nothing to do with the angle. I expected the answer to be negative. It has to, because it's in the second quadrant. Tangent is negative. Good. So now I have to think of something else. How can I get a 15? Knowing only 3 angles. I know 30, 45, and 60. I have to create something that replaces 15.
45 minus 3.
That's it. I agree with that. So this is minus tangent 45 degrees minus 30 degrees. Awesome. And I'll apply the same formula again. Minus outside. Tangent 45 minus tangent 30 over 1 plus tangent 45 times tangent 30. And then you will say, but you told us not to remember tangent. True. But tangent 45 is sine 45 over cosine 45, and this is the only angle for which both are the same. So what could be tangent 45 equal to? 1, of course. Now let's think about tangent 30. Again, we have not memorized tangent 30, but I know tangent 30 is 1/2 over the square root of 3 over 2. So when I flip, I get 1 over the square root of 3. Right? 1/2 over the square root of 3 over 2. 1 over the square root of 3. I'll keep it as is for now. I will not rationalize. You'll see in a moment why. Over 1 plus the same thing. Is it clear what I'm doing? Is it clear why tangent 45 is 1? Is it clear why tangent 30 is 1 over the square root of 3? Do I have to show it? Please say yes, and I'll show it. Okay? So I know sine and cosine for 30, correct? So I know that sine is 1/2, and I know that cosine is the square root of 3 over 2, and I have to flip. 1/2 times 2 over the square root of 3. 1 over the square root of 3. Is that okay? Good. So now I have to continue and simplify it as much as possible. The negative stays outside. Least common denominator, least common denominator. Yes, in both cases. The top. Awesome. The top. Yes. So now minus. I copy and I flip. What goes away? Now I need to rationalize. What do I rationalize by? You thought you could forget about rationalizing. No. Yes, which is? You said the conjugate. This one has plus.
Oh, I'm sorry, minus.
Exactly. Good. Minus outside. The denominator, please. We have an agreement on the denominator. Do not FOIL, please. 3 minus 1. Perfect. The top. We have an agreement on the top. It's the square root of 3 minus 1. Everything squared. How many terms will you give? A binomial squared is? Yes. Good. I'm ready. The first term squared. Minus 2 times the first times the second. Very good. Plus the second term squared. Awesome. Minus. How much is 3 plus 1? How much is 3 minus 1? I will separate into two fractions. When I separate, 4 over 2 is minus 2. The square root of 3 over 2 will be, that's it. I have to distribute. Separate the fraction. 4 over 2 is 2. 2 the square root of 3 over 2 is the square root of 3.
So the next test can be like 3 problems.
No, you're going to get used to it. Okay, anything else, or we move on to the next set?
You said there was a better way to do it.
I would have not started with 180 minus 15. One option would have been 90, but I would have gotten in trouble with tangent. So one option would have been, for me, to change tangent into sine over cosine, finalize the top with sine, finalize the bottom with cosine, and referring it to not 15, but 90 plus 75. And I would have used 45 and 30.
For the next one. Yeah.
I don't know how much shorter we would have been, but I would have personally gone that route. Separating it, not worry about the fraction tangent. I would have worked on sine separately and cosine separately and then put them together. Maybe it's shorter. Okay. Anything else from 3 through 14? Moving on. Okay, 15 through 20, please. 15 through 20. Okay, I will choose 20. And that is cosine 13 pi divided by 15 times cosine negative pi over 5 minus sine 13 pi over 15 and sine negative pi over 5. What do you think about this? So keep in mind that it looks how? It looks as? Can anyone read it without angles? Just read it with no angles. Cosine minus sine sine. There is only one identity for that. What is the identity for that?
Cosine 13 5 or 15 plus.
It happens that this is a negative angle, so I'm going to write negative pi over 5. I have to write plus because this is minus, right? This should have been plus. But since this is a negative angle, is it done? No. I have to find the angle inside. So I need the least common denominator for cosine, and the least common denominator is
15.
good. And the second one gets multiplied by good. And then I have 13 pi minus 3 pi, which is
10.
yes. And now I have to simplify 10 and 15 by
2, 5, 3.
yes. So this will be 2 and this will be 3. And since the denominator is 3, I know how to calculate this. If the denominator is 3, 6, or 4, I have to give the exact answer. If the denominator is 17, I'll say, sorry, I can't. I don't know, depending on the problem, though. So cosine 2 pi over 3.
0.
Not so fast. 2 pi over 3 is an angle in which quadrant? What angle is this one? What angle is this?
60.
Times 2.
Yeah.
Good. What is the sign of cosine in the second quadrant? What is the reference angle of this angle? So then what do I write here?
Negative 3 over 2.
Cos. Yes, yes, you're right, you're right.
So sine of pi over 3 is equal to negative square root of 3 over 2.
Sine is the square root of 3 over 2. Cosine is 1/2 for pi over 3. Sorry about that. You're very powerful today. Don't tell me to jump from the Empire State Building. So remember this is pi over 6, pi over 4, pi over 3. So this is sine and this is cosine. 1/2 the square root of 3 over 2, the square root of 3 over 2, 1/2 the square root of 2 over 2, the square root of 2 over 2. So it's negative 1/2. Very good. So let's move to identities, please. 25 through 42. Please choose. Let's look at identities. Okay, I will choose. Let's say 38. In 38, we have 1 minus tangent x tangent y. They say it equals cosine x plus y over cosine x cosine y. So which side will I start with?
Left side.
If I start with the left side, yeah, you know what? Let's start with the left side. I would have started with the right, but I want to start with the left now because it's pretty much the same.
Okay.
So 1 minus tangent x tangent y. I think that if we had started from the right, it would have been easier because we know what cosine, but it's the same thing. So I agree with the left-hand side. So this is 1 minus
X over cosine x. Sine y over cosine y. Cosine x. Cosine y.
very good. And now the numerator.
Cosine x. Cosine y. Minus sine x. Cosine x. Sorry, cosine y.
So this gets multiplied by this product, cosine x, cosine y. So I have this times 1 minus this product. I cannot invent anything. It's a product.
Oh.
It's a product. Don't try to multiply the top of a product.
Yeah.
This is just one fraction. This is one fraction, sine x sine y over cosine x cosine y. The product, when we multiply fractions, we never find the least common denominator.
No, I was
Okay, so then I have sine x.
sine 1.
Very good. Now, what do I do? I notice something, that the top can be replaced by, yes, awesome, which is
Cosine x plus y.
and now
To the right.
done. Okay, please choose.